Hello, welcome back. So I hope you enjoyed the preview video of this hand tracking and ScriptDAT demonstration. So now we come to the real things. So as before, I start with a video device in, which is the webcam image, and then I also changed the resolution into half, which supposedly will make the detection a bit more fast. And then before we proceed with this one, let's have a look of some background data. Okay, so the first thing is we're going to do the ScriptDAT objects. So for this one is the data operator. So everything we're going to do will be something appear like an Excel worksheet with rows and columns. So I use it mainly to maintain, for example, like the different points in my hand. So it's have the name called landmarks or hand landmarks in the MediaPipe terms, and then keep it in a table which looks like an Excel worksheet. And for each of the row is the point in my fingers, and then for column will be the X, Y, Z coordinate. So the data come from MediaPipe. So the MediaPipe is actually a very good piece of software or framework that we can make use of in different platforms, like in Android, web, Python, and iOS as well. I believe that the MediaPipe plugin in TouchDesigner is already developed in the web platform that communicate with TouchDesigner remotely, not remotely, through this kind of web sockets or similar types of technology for communication. So for the one I'm working on, I try to make the Python code running in the script DAT and then have the result showing in an DAT operator and then convert it into an SOP. That's the surface operator for 3D manipulation. So for the detection, it's pretty straightforward. By default, it is detect one hands, and which will show you this 21 pieces of information from your wrist, and in with 5 fingers and with different joints that you can locate the position information. So this is the one we're going to show up here in our exercise later. So the one we're going to use is the Python version. So we go through them. Actually, basically, I just copy and paste most of them and then put it into my example. So the one come with 3 options. One is image, which is for still image. That's not our case. And video or live stream. So apparently we are using a webcam, we should use the live stream. But the live stream one actually in here, this come with the async operation. That means there's a callback defined here. So for our case, we don't use the callback here. So we'll use the video with a bit more synchronized modes of operation, which use the onCook function in our ScriptDAT. So that is the one we're going to. The result is going to be displayed something like we call a landmark with the XYZ data that you can put it in a 3-dimensional display. So let's have a look at what we are going to play around with. So before that, I can also show you in the past, I think a few years ago, I also worked with the MediaPipe and TouchDesigner in my personal website in a blog. So I also put the link in the Patreon that you want to have a look, that you can check out the blogs. Then there's quite a number of information that you can have a look for using MediaPipe in TouchDesigner. So let's go back to TouchDesigner. Okay, so let's make a null and then call it input. And the core thing we're going to do will be a ScriptDAT. Okay. By default, it's also come with these two dummy parameter, which I do not want to use. So in that case, I will replace them by something that we need to use. So the first thing we need to do is to accept a TOP, that is the video image. I give it a name called image with a label of the same name. And the second thing that I'll explain in detail a little bit later, which will be UI, is a toggle button. So for this one, I name it aspect, which is the aspect ratio, because the coordinate that we turn from the landmark is normalized in the range of 0 to 1. And it's also normalized in terms of of a square. So if you are using a rectangular shape of input information, so the aspect ratio needs to change. So in that case, I keep a toggle button that you can have the option to whether you would like to apply the 16:9 ratio to the y coordinates as well. So this is something I can name as aspect ratio, and then with a label called scale in y direction. So that is another command I'm going to use. So in that case, okay, let's still have an error. Let me have a look. Okay, return. That's an extra code here. I put it wrongly. So in that case, we can set up, and then we have the image and toggle. So normally I will turn it on to have the aspect ratio adjust. So then I can put our video image here. So the next step we are going to do is to read in the input texture and also the value of this toggle button. Okay, so I define input similar to what we have done in the last couple of tutorials. This one is a parameter image. Need to evaluate and then to extract the numpy. And in order to use the numpy array, I also need to import something that we need to do every day. Okay, and then I define another one. And before that, I need to check if input is none or not. If it's none, I just skip and return. If this is not none, and then I change it to integer 8-bit as usual. And then convert the color space from RGBA to RGB, which will be used by the MediaPipe for detection. Okay, so if you want to, can have a look. The shape. Oh, color, yes. A is missing. Yes. Similarly, for the button, we can also obtain the button value. I just name a variable called aspect to take in the parameter aspect. And depending on whether you click this one, turn on or not, so it will return true or false. So if it is true, so we need to define a ratio that will be the aspect ratio by dividing the y with x, else we just keep it to 1. So that is the aspect ratio conversion. And so what happened to this script date? So we need to put in information around here. So for that reference, so we can check out the TouchDesigner documentation of this one. We're going to use it later, DAT to SOP. So what I intend to do is put all my finger information into the DAT and then use the DAT to convert into our 3D objects. So the table has some kind of predefined format for the point in my finger. So you need to have P0, P1, and P2, and the rest can be optional, like the normal and the point weight. So 0, 1, 2 correspond to X, Y, Z. I also need to create something called the primitive DAT later, such that I can connect different joints of my finger into like a straight line or a polygon that I will go with it later in a moment. So that is another table that I need to fill in here. So let's get back to our TouchDesigner. So in order to use the MediaPipe, you also need to import the MediaPipe into our Python program. And I also need to import a number of other libraries for calculation later that I will explain. So datetime is to try to get the current timestamp that will be required for the operation in the checking of or detection of my hands around here. I'll explain in a moment. So in order to save the typing time, I already create the Python file that I put it in the attachment. You can download for copy and paste later. So the first thing is we need also to download the model file, which you can obtain from here. So this is the link of the model file that I already put it in page one that you can use in the attachment as well. And the model file will be inside the project folder of your TouchDesigner project. So for that one is referring here. And then we're going to copy and paste all of this into our ScriptDAT. Okay, so this one will be the model file. And the second one I need to explain a little bit is as I mentioned in the detection for video and also for live stream, it needs to have a timestamp. So timestamp is actually an increasing integer that indicates passing of time for each frame of the video. So the easy way to do is can get the latest time and then get the timestamp in milliseconds. So I need to multiply by 1000 to have the millisecond and then make a floor to get the integer. And then later I will get the latest time again, then minus the starting time in order to have an increasing integer for the timestamp operation. For the rest will be just some of the definition of the objects and also the variable name, and which is actually a short form written in here. So the important thing will be this one. So the running mode is video or live stream. If you would like to use, for example, like the callback. For my case, I don't use it. And then you put the option here to create the object for the hand landmarker detection. So that is the detection. So the actual detection come into here. So we have the image, but before we can do the detection, we need to convert this image into something readable by the MediaPipe. So that one come from here. So you need to do the preparation. So that is the MP data or image that you convert from your NumPy, that's your OpenCV array, into a format of sRGB expected from MediaPipe. So I just copy and paste, or you can also copy and paste from the Python file I provide. For this one, remember to rename this one to our variable called image that we have prepared. So the last one we're going to do is actually perform the detection, which I need to prepare the timestamp as well as the actual detection. So I copy and paste here. The first one is get the current time that now, and then minus the starting time. That's the beginning of running this piece of code, and then minus, it will give you an integer. That integer will be increasing one frame after another. And then we're going to do the detection for this image together with the timestamp. And then we can check out the result, to print the result to have a look. So it might take some time for you to initialize the MediaPipe. So if you do not raise up your hand, you're going to see everything will be an empty list. If you put up your hands in front of the camera, you'll see that information of X, Y, Z. So what we're going to do is to extract the hand landmarks, which will fit into our 2D image. And the handedness is actually indicate whether this is a left hand or right hand. So we are going to take a look at the second parameter, hand landmarks. And start to run again. So if you have no hand, it's an empty list. But if you have a hand, so it come up with a list of your hand, finger, digit information. So the first thing we're going to do is check whether this is an empty list or not. So the checking can be done like this. If the length of this one is greater than 0, and then we start the processing. So our hand is the first one because we only detect one single hand. And if you prefer, you can actually detect more than one hand. So for simplicity, I just take the first one because we are detecting just one hand. And then you can have a look of this hand information, which is here. That is the normalized landmarks with the X, Y, and Z information. So the core thing for this one actually we need or we want to fill in our Excel or worksheet with all the table informations around here. So we start to work on with this one, which is the core part of our ScriptDAT. So we already cleared the table. So in order to fill up the table, we need to do something called append row. So that means we try to append one row one by one to fill up the table. The first row will be our heading information, so that will be the description of X, Y, and Z. So in the 3D shop name, it is the P0, P1, P2 position. So we coped, this is a string, so I need to put 3 of them. So for this one, anyway, it will come up with the header, even though it had nothing or no hand showing up as well. So the next step, or probably the final step for this program source, will be fill up all the hand information of the 21 piece of data from here. So that is the one we're going to do. So for hand is actually, I use a name LM, that's the landmark. For the hand, it will display 21 of them. And then for each one of the piece of information, I append one row of data in our table. So the first one will be the X, and then the second one will be the Y. And the last one will be the Z. But for the Y, we also need to do a multiplication of the aspect ratio in order to fit in our 16 by 9 rectangular display later. So now we have this one. So appending each row for each of the landmark detected with your hand. So you can see if you do not raise your hand, you have nothing. But once you raise your hand, you see this piece of information. Yes, so those are the information correspond to the position of your hand. So that is something we would like to work on with now. So how to make use of this thing is I just put it in a null that first and name it at point. And then for the SOP, I choose that too. And then we drag this one to the point. And then it gives you a crossover here because we don't have a primitive that around here. So for the primitive that actually there will be another table that we can type in by ourselves, which corresponding to the vertex and whether the polygon is closed or not. So for the TD is the diffusion color, I think. So I'm not going to change the color at this moment. So we just skip this one, just keep the vertexes and closed. So for this creation is pretty simple. You find from a DAT and then you choose a table. And then you can click on the Viewer Active buttons around here to insert another column. The first column is called vertexes. The second column is called close. You can also click on the row number to insert a number of rows around here. So for example, if you want to visualize and let's choose one finger. For example, the index finger is come with 5, 6, 7, 8. So we just put in 5, 6, 7, 8. For the close, we put it 0 because it's not a closed polygon. So it's just a sequence of line segment. So now we can just use this single one. I give it another node with a name called primitive. And then drag it here to the primitive. So with the hand, so now you can see my fingers. So this is single index finger. So if you want to, you can add other fingers as well. So I'm going to add my thumb. So my thumb number is 2, 3, 3 and 4. So 2 is the MCP, which I'll use it to connect the palm later. So I just keep I can start with 2, 3, 4. Is it okay? 2, 3, 4. Again, it's not closed. And then I proceed with my middle finger. It's 9 to 12. Again, no close. Next one will be my ring finger, 13 to 16. Again, no closed. And then the last finger is the pinky one, which is 17 to 20. Again, no close. And if you want to, you can also add your palm. So I can have a demonstration how you can add the palm and close it as a polygon. So it's begin from 0, 1, 2. And then start moving 5, 9, 13, 17. And for this one, it's not like the other. It's a close because you want to close the polygon type of surface. So you can have a look of this primitive. If you update this one, and for the hand that you create, is something like this one. Is a model like a hand. Okay, so the next step is I try to visualize and put it back onto my video. That can be a little bit tricky, so I add a node and call it hand. And similar to auto 3D processing, so you need to have a geometry. And then you have a camera and also light. And eventually you render everything in a render top. So you look like something like this. And then for the render top, we're going to overlap it on top of my original video. So I connect using composite. Put it to the output window and then put the video under my hand. So if you want to, you can all further customize by using material. And we'll try using a wireframe first. And can choose a color. Just show the topology. If you want to, you can increase the thickness of the one line. And then to use it as the material. So now you are going to have your hand like this one. Unfortunately, if you do nothing, so your hand will be a little bit off from here, because in order to overlap our 3D image with our 2D video image, and we might need to customize a little bit of our camera. So camera at this moment is using perspective projection. So but if you want to have this kind of AR effect overlapping your generated image into the 2D video, so you might need to choose the orthographics. That's the parallel projection. And then the screen width is 1 instead of 2. And then the orthographic projection origin, the center is not in the center of the screen, as you understand from this information from here. So the information comes from 0 to 1 relative to the bottom left center. So that is the arrangement. So we make some changes to the camera setting and then try to have a look again in this full screen display. So now you can see my hands and also the drawing of my figures around here. So this is the design that you have that come with this. Okay, in the preview video that you can also see that I can switch between different drawings of the hand. So that's done by choosing different primitives. So this one is a comprehensive one. We make use of all those numbers. And if you imagine, I just want to go like the perimeter that the surrounding of your hand, starting from 0, 1, 2, 3, 4, and then just the fingertip that you can create a polygon of the outline of the hand. So I can do this one as a demonstration. And with another table, I just copy and paste. And then I delete most of the other row and just keep the last one, which I would like to build a polygon. So that is 012. And then I can proceed with freeform. And then that one go to before I'll skip the 5, 9, 13, 17. I'll proceed with the 8, 12, 16, and 20. 12, 16, and 20. And then I can return from here 19, 18, and 17. 19, 18, and 17, and eventually back to 0. So this is another one I can use. So if I connect this one to the primitive, then you can see that it becomes just a polygon, and then outline everything around my fingers. So the effect I have done in my demo is actually I make a switch to switch between these two tables before I send it to the primitive. So that is pretty straightforward TouchDesigner techniques that common to top, chop, and that. So it's a switch. So the default one can be this one. Oh. And the other one is the outline one. So the switch result will send to the now primitive will be used by that. Okay, to switch among them, just between them, just 0 and 1. So I can automate it. So probably I can also add one more to make it a little bit more interesting, but it takes time to do so. Okay, I can add one with different finger. The first one, 2, 3, 4. Or I can, it's a little bit easier here. So I just copy this one and paste. And then delete. Okay. This is the second one. This is the third one. And then I just delete the final polygon and keep the 5 fingers. Okay, so now we have 3 drawing of our hands of 3 geometry. And then we can think of the way to alternate among them. So one of the easy way is to use a keyboard, but I prefer not to because it's quite difficult for you if your hand around here and then you use another hand to press the keyboard. And the tricks I use in my demo is I take a look at this one. This is the point. See, I have hands around here. So the number of rows will be much greater than without a hand is 1 row. And with the hand is, I think it's 22nd or 22 rows. So I can make use of something like an info chart and drag this one to here. And select the only variable or only property as number of rows. So it's 1 and 22, 1 and 22, 1 and 22. So just make use of this one and put it in logic. And then choose off when outside bound. So the bound I define is 2 to 22. That is the number of rows with the hands around here. So with the hand, the number of rows actually is 22. So it will become 1. And then without that become only 1 rows, and then there will be 0. And I will also add another one usually for explanation or for teaching. So I'm not going to look up the logic again. And then try to detect only the rising edge. So that means change from 0 to 1 for detection. So rather than detecting falling edge then or staying stable as 1. And I will use this one to drive a counter. So for the counter, depending on how many join that you have. So for this one, we have 3. So the count will just loop through the minimum from 0 to 2. And then the counting will be done by this trigger. So whenever there's a hand enter into the scene, so it will count. So that one will be a count that we use to connect to our switch. So I can just drag this one that is the count to the index in the switch and then export the chop. Or you can use the Python expression. So I minimize the use of Python expression by using export chop. So in that case, you can switch among different representation of your hand by waving your hand in front of the camera. So the result will be something like this.